And we're live.
All right.
All right. So let's go ahead and start reviewing the preparation assignment.
Okay.
And we're going to read one by one. So I'll go ahead and read the first one. Number one, part one. One of two conditions must be satisfied in order for the distribution of sample means to be normally distributed. What are the two conditions? And one of the conditions that we've seen so far is that the parent population is normally distributed.
Mm-hmm.
So that means that the sample mean is automatically normally distributed also.
Normally distributed. Okay.
And the second one is that if the sample size is large, due to the central limit theorem, the sample mean will also be normally distributed.
Okay.
Does that make sense?
Yes. Yep.
Okay. Who goes for the second one?
See.
You want to go, Jane?
Sure.
Okay.
All right. So let's see. The second one says, what is the z-score formula for a sample mean that is normally distributed? And so, let me look at my paper here. Hold on. I got a lot of notes. Taking 4 classes. 4 classes this semester.
Oh, too much.
Yes.
Really?
No.
That's a lot.
That's I know. At work, on my lunch, I do homework during lunch.
We do the same thing, but 2 classes is a lot. Even 2 classes is a lot.
Yeah, it's a lot of work. Okay, so I have Z. All right, so number 2, what is the z-score formula for a sample mean that is normally distributed? So then it should be Z equals sample. Let me see, hold on. Mu, sample minus mu, over, does that sound right?
It's a sample minus mean divided by sigma divided by
yes.
The root square. By the root square of the number.
Square, yes.
So what it means, what it is.
Okay, so that's right? Is that
okay? Yeah.
I get
Right.
Okay.
Okay.
Yes.
Number 3, it says suppose a normally distributed population has a mean of 10 and a population standard deviation of 5. What is the probability a randomly selected individual observation is between 5 and 15? If we use the rule 68, 95, and 99.7, because the numbers are between 1 standard deviation point, so that's 68%.
Okay.
Okay. That's right.
The next one, B, is what is the 40th percentile for this population? And that'll be 8.73333 and beyond the infinite.
Okay.
Okay.
What about C?
So the z-score is 1.7. 1.7?
Yeah, that's correct.
Okay.
Okay, and number D, what is the probability that an individual observation is greater than 12? Okay, I got a z-score of 0.4 and the area or probability is 0.345. 446, yeah, or 45, rounded.
All right, so E. What is the probability that an individual observation is less than 8 or greater than 12? So we pretty much take each side, which is the same result that you got, Rosalia.
Okay.
0.3446 plus the other side, which is also 0.3446. That'll give us 0.6892.
Okay, great.
Okay.
Part 2.
see. So, let's see. Shh, you guys, shh. Hold on. Okay, sorry about that.
That's
No
okay.
problem.
Okay. Let's see. So part 2.
Yeah.
All right. And actually, so that's as far as I got for
Oh,
this.
okay. Don't worry. We can continue.
Okay, I'll go ahead and read the next one then. It's well,
Okay.
it says suppose per computing sold an average of 45 P phones per minute in 2011, whatever that
Okay.
means, with the standard deviation of sigma equals 10. And they looked at their P phone sales data and determined that they are normally distributed. So number 4 says samples of size n equals 4 are taken from the normally distributed 2011 sales data. What is the shape of the distribution of X? And that one would be normal.
Yeah, normally distributed. Okay, for
Right.
number 5, the sample size is 40. So it says taken from the normally distributed 2011 sales data. What is the shape of the distribution of the mean? Well, normally distributed because the question itself is telling us that they're normally distributed.
So it would be
Okay.
normal?
Yes.
Yes.
Normal. Okay.
6. So sample size of n equals 4 is taken from the normally distributed. Okay, what is the probability that the observed is greater than 40? Greater or less?
Less.
Less, right. So I went ahead and checked that out, and we used the 60, 90, 95, and 99.8 rule, 99.7 rule,
Mhm.
and I got the 0.1587
Okay, I use the applet.
result.
I use the applet for this. So the next one is a sample size of 4 is taken from the normally distributed 2011 sales data. Where is the probability that the observed mean is greater than 35 and less than 55? And using the applet, I got 0.9545.
Okay, yes, that's about right.
Okay.
8. So what is the probability that X is greater than 41 and less than 49? And it's the same result I got. It's 0.9545,
Okay, and number 9.
which is a 95%.
What is the probability that the observed mean is greater than 50? And that's 0.00621. And the C score was 2.5. Was 2.5, and so the probability or the area was very small.
Okay.
Okay. 10. So we got different variables here. And it says, what is the shape of the distribution of X, taking in consideration that the samples of size 4 are taken from the right skewed 2010 P phone sales data. So that'll be right skewed.
Yeah, because the sample is small,
Okay.
right?
Because it's a small, it's a small sample, right?
Okay.
Okay,
And
yes,
for-
that's what I got.
Oh,
Okay.
yeah, okay. And for number 11, since the sample size is greater than 30, here it's 40, then it will be approximately normal, the shape.
Okay.
Okay.
I got that. Okay.
12. What is the name of the theorem? And that's the
The
central limit.
limit theorem. Right.
Right.
Okay.
13.
Okay, a sample size of size 4 is taken from the Right Scoot 2010 phone sales data, and you want to know the probability that the observed mean smaller than 35. Can you compute this probability using the normal probability applet with the information you have? Well, since the shape is not normally distributed, and the sample size is 4, which is smaller than 30, we cannot, because it must be normally distributed or approximately normal, so
Okay.
we can't.
Okay. Okay, got it. Got it.
14. 14 asks, what is the probability that the observed x is greater than 36.5? And that's the 95 rule. So about 95%,
Mhm.
0.9599.
Okay.
No, I think that's the because the sample size is 36, and then you get the z-score, which is minus 1.75, and it is telling us greater than that, so that's 95, 99, well, 0.9599, and the 95 percentage is 95, 40, 95, 45. So it's
Oh, you're right. Yeah.
Yeah.
Okay.
okay.
Number 15.
Oh. So, okay.
Okay, number 15. Well, the sample size is 36, and what's the probability that the observed is between 37.5 and 42.5? So the z-score was minus 1.25 and 5. So the probability between those numbers was 0.7887.
Okay. Got it. Got it.
Okay, I think that's it. Any comments? Any questions? No? I'm going to stop
I'm
broadcasting.
catching up.
Okay, hold on. Let me stop
Okay.
broadcasting.